Hello again everyone, welcome back to ptet.chemistry channel. My name is Dr. Ont. In this tutorial video, I'll go through this 5129. This is the combined science, or you can call it coordinated science, which is basically the triple sciences condensed into one subject, and as such the contents are a little bit more diluted. So this is the chemistry component where I'll go through this work 2 associated with the metals assignment. So following on from the lecture tutorials, there are a couple of things stated in the syllabus, in the curriculum learning objective. So one of them is basically the case study of aluminium, which is a very important metal because aluminium is used to build parts of aircraft, and what makes it useful because it has different property that you have to assign, or you have to correlate with whatever you are using it for. So for aircraft, it's a result of its low density, its lightweight and stuff. So you can talk about that. Whereas for food container, it is resistant to corrosion, as we have learned that there is a protective aluminium oxide layer around the aluminium, and that is why it makes it resistant to corrosion, and therefore it doesn't react with your food, and therefore it is safe for you to store your food as a container. Question number 2, so we have to link the element, the metals, and some non-metals with their uses. So copper is used to make electrical wiring. Aluminium is used to make food container. That was following on from the first part of the question. If you read correctly, aluminium is used to make food container because it's resistant. It doesn't corrode easily because it has a protective aluminium oxide layer. Chlorine is used to treat drinking water because chlorine can kill bacteria, it can kill microorganisms. It's the last step in water treatment after the first step of filtration, second step of passing it through carbon, which is the black solid carbons to remove bad taste, very foul taste or foul smell, and then lastly you add chlorine to kill off bacteria. Nitrogen is used to make ammonia. In year 9 chemistry, ammonia is nitrogen combined with hydrogen, and because of the 5 electrons in the outer shell, because it is in group 5, whereas hydrogen only has 1 electron in the outer shell, nitrogen share 1 electron with each of the hydrogens, and as such, I only use 3 out of 5 of my outer shell for bonding. I am still left with 2 more. That is the dot and cross. If I draw the display formula, this is what it looks like. Dot and cross, show dot and cross. This is what you call display formula, where we have learned this all in year 9 as part of covalent bonding. So nitrogen is a reactant in making ammonia. Ammonia is very important to make fertilizers, which is of course very important in the global agriculture industry there. Argon is a noble gas. If you see the periodic table, argon is 288 electronic configuration, fully filled outer shell, therefore unreactive as an element. Because it is unreactive as an element, and that is the reason why we can use it to fill light bulb, and it will be safe because it's an inert or it's an unreactive atmosphere, it doesn't react with anything. As a result of this fully filled outer shell as a noble gas there. This next question is about reactions of 4 metallic elements, and we're reacting with hydrochloric acid and water. So 2 different reactions there. We have metal plus acid, and we know metal plus acid will give us metal salt, and we also get hydrogen gas. Whereas metal with water, we expect to get metal hydroxide as stated in the syllabus. We don't get a salt because we don't have an acid there, but we also produce hydrogen gas. In both of these cases, what we see really is we will see bubbles because you don't really see the colorless gas, you see bubbles, and then you test the bubbles with a burning or a lighted splint where the fire is still going, the flame is still going. Hydrogen gas will burn with a pop sound when you use a lighted splint. When you see the reactivity of X, Y, W, and Z, you can see that if we want the most reactive versus the least reactive, because these are the most extreme cases that we have to consider. First of all, we have this word violently. Violently mean vigorously. They all mean the same thing. Violently, vigorously, very, very reactive. And hence, if we are looking for the most reactive stuff, none of the other one is violent. So I would say Y is the most reactive metal because of its violent reaction. Violent kind of explosive, yeah. Whereas you also have does not react with acid, does not react. So you do not react at all with acid. That's going to be the least reactive of all. How do you decide between X and Z? Well, what we see here, the difference is X react with both of them. It reacts with both of them, whereas this one not with steam. So therefore we can say Z is less reactive than X, because X also react with steam and acid, but Z does not react with steam. So Z is going to be less reactive compared to X, which is going to be more reactive compared to Z there. Now, a lot of students get confused between the English word. Okay, this is not English, but rather we are talking about the chemistry terms, because when we have the oxide of W, so this is the metal oxide, and what you're doing is you are reacting it with hydrogen, and the hydrogen takes away the oxygen. The hydrogen takes away the oxygen. What the metal oxide does is the metal oxide lose the oxygen and become the metal, and you will get H2O, which is basically water or steam. So when we say it's getting reduced by hydrogen gas, what we can see is the metal oxide becoming metal. So yeah, the metal oxide, which is basically the oxide of W, loses oxygen to form metal W. Okay, so this is oxide of W, is a compound. Metal W is the element. Loss of oxygen is what you call reduction. That is part of the year 10 redox topic, and that is the meaning of the word reduce here, not the English word, but the proper chemistry term. In terms of reactivity, so this is reactivity series. We know about the Po, So, Ka, Ma, and then the Zil, zinc, iron, lead. We also know about hydrogen is below lead, and then copper, silver, gold. So we have an issue here where we don't know what is W, but we don't really need the Po, So, Ka, Ma, Zil, because this thing tells us that the oxide of W is reduced by hydrogen. So what we can say is hydrogen can displace metal W from the oxide of W. So therefore, hydrogen is more reactive than W. And that is the reason why you can displace the metal W from the oxide, because they are more reactive than W itself. Now state one physical property all metals have in common. So what you can think about is really all metals conduct electricity. All metals conduct electricity very well because they have high or good electrical conductivity. That is basically saying the exact same thing. High or good electrical conductivity basically is the same thing as saying that you conduct electricity very well. Now the next question, this is part of environmental chemistry. I think we did this lecture a while ago, so if you look through the topical playlist, you will find this environmental chemistry, which is essentially geography, but we also have to relate it to our syllabus and not just referring to the internet. They want name 2 gases. From the syllabus, there were 4 gases in the environmental chemistry for the combined science. I think there was a carbon monoxide. So carbon monoxide is produced from incomplete combustion. So incomplete combustion means you don't have enough oxygen, so you get incomplete combustion of fossil fuels such as from your cars. Whereas carbon dioxide, you get it from complete combustion. So in excess oxygen, when you have enough oxygen, you will get complete combustion. You use fossil fuels in your car as your gasoline. And then we also have other gases such as methane. There's another environmental pollutant, air pollutant. And methane is from decay of vegetation matter. When you grow a lot of vegetable and when they decay because they will go bad over time, then they will release large amount of methane. Or you can also say gases from burning plastics. That was also in the syllabus. So gases from burning plastic, those are toxic gases. And of course, where do you get it from? From burning plastic. So that one is quite a obvious one. It's stated in the syllabus back in the environmental chemistry on air pollutants, together with the environmental chemistry of water. Now describe an effect of one of these gases. Make sure you specify. So here I have used carbon monoxide. A lot of people get confused. So carbon monoxide is not a greenhouse gas. Carbon monoxide is a toxic or a poisonous gas. It will kill you. Okay? Or they just say one of the gases, or I can say carbon dioxide. So I specify carbon dioxide. Or I could say methane. Just name one of the gas that you have chosen in the first part. These are greenhouse gas. So both the methane and carbon dioxide greenhouse gas. Therefore, it causes global warming. Global, around the whole world, it is getting hotter and hotter, and that is global warming. You can also say the gases from burning plastic is the same effect as carbon monoxide. Those are toxic or poisonous gases. Next question, state the type of chemical reactions. Temperature increase. So the outside is getting hotter. So the surrounding, we said that the surrounding or the outside is getting hotter. Why are they getting hotter? Because what we have is an exothermic reaction that releases heat to the surrounding. As a result of the combustion of methane, so you're burning methane, so you uses up oxygen. You uses up oxygen for combustion. If you have excess oxygen when you burn methane, you are going to get carbon dioxide, complete combustion of methane or fossil fuels. Carbon monoxide, if you don't have enough oxygen, you're going to get incomplete combustion of your methane. And what is the effect on the number of nitrogen molecules? No effect, because combustion only uses up oxygen when you are combusting. So oxygen molecules will be lesser or lower because it would have used up, consumed, totally used up the oxygen after all. Now, during the combustion of fossil fuels, carbon dioxide is produced. Like we discussed previously, you can get carbon dioxide from complete combustion of your fossil fuels. What is the test for carbon dioxide? Some students get confused and put results under the test. You need to read carefully. What we do is we collect the gas and we bubble the gas into lime water. We bubble the gas into lime water where we have a setup like this. So a side arm. And then we bubble it into these test tubes. So here is your lime water. I want to collect the gas inside there. So what I'll have is I will have a seal. This one is a seal, meaning it's totally closed. So all the carbon dioxide from here that I am burning, I guess. And then if I'm burning off the methane, so this is methane burning or combusting. And I am producing carbon dioxide, and the carbon dioxide bubble the gas into lime water. What happened to the lime water? The lime water will turn milky or cloudy. That is the positive result for carbon dioxide gas being present, and that will be the 2 marks there. In this next question, we have the structure of an atom of fluorine. So this black color thing is protons. If you count the protons, 1, 2, 3, 4, 5, 6, 7, and then 8. And I think I'm missing one. ninth. And how do I know it's ninth? Because fluorine in the periodic table, group 7th, you can see that the fluorine is given the periodic table as 9th and 19th. They told you that this is the atomic number, and they also told you that this is the relative atomic mass. Back in year 9, we know the relative atomic mass is not the same as the international standards, where here we have 9 of these black color protons. We will put that 9th at the bottom left. This is proton number, which is equal to what you call atomic number. Whereas we have the mass number, which is how many white one do you have? You have, let me just shade it with pink color perhaps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 of these pink color neutrons. So I have 10 neutrons, but I also have 9 protons, and therefore altogether I have 19 nucleons. So there's 19 nucleons. So nucleons are all the particles in the nucleus, which include the protons and the neutrons. You have 10 neutrons, you have 9 protons, so your 19th is your nucleon number. Nucleon number, which is your mass number, as stated in the year 9 syllabus under atomic structure. So nucleon number, not neutron number. This is equal to the mass number, is equal to the number of protons plus the number of neutrons. So basically that one is 19, and the number of proton is just 9 there. Complete this figure. Wherever there is mark, you got to read the question. Atom of fluorine, 2,7 electronic configurations. The first shell and then the second shell, and it is a second period element, and it is group 7th, so therefore 7th outer shell electrons, or 7 electrons in the outer shell. So I can draw 2 in the first shell. Let me just remove all of these coloring here. So 2 electrons in the first shell, and then 7 electrons in the second shell. 2,7 electronic configuration to get the 1 mark there. Now fluorine is in group 7th. What is the general name given to the elements in group 7th? This is halogens chemistry. How does the reactivity as the group descend? That means down group 7th. As you go down the group 7th, you have fluorine, chlorine, bromine, iodine. When we learn the displacement reaction, we learn that the more reactive halogens can displace the less reactive halogens. So we know that these are more reactive on top of the group 7th, and then it becomes less reactive at the bottom of the group 7th. Those color changes as the more reactive halogens displace the less reactive halogens from the halide ions. These are all in the periodic table, group 7 case study chemistry. So reactivity for the group 7 nonmetals is the opposite for the metals in group 1. So this decreases down to group 7. Be very, very careful. The next bit is a 2-mark question. Fluorine is a non-metal. How this can be deduced from the symbol? What does the symbol means? The symbols basically means 9 protons, and this is 19 nucleons, which is equal to 9 protons, and, or you can say plus 10 neutrons. But what they want is also electronic structure. So what else can I comment on these? Well, it's an atom. So atom overall is uncharged. If overall is uncharged, therefore number of electrons equal to number of protons. As overall you have no overall charge. So how many electrons do you have? You must have 9 electrons. So therefore 2/7 configurations, 2 in the first shell, 7 in the second shell, and that is what we can deduce about the electronic structure there. Last but not least, we have fluorine. Fluorine is F2 diatomic group 7 element, as stated in the periodic table topic. It has 7 electrons, so 7 crosses, share 1 dot with the neighboring fluorines, because now you have a single covalent bond for group 7 diatomic molecule. Magnesium is a metal, so this is a metal, whereas this diatomic molecule is a non-metallic elements. Metal and non-metals, they will combine together to give you an ionic compound. You want the bonding, this is called ionic bond. You also want the name of the white solid, so the fluorine form compound, and with the magnesium, you want the name, this is going to be called magnesium fluoride with the IDE, because that is Mg2 plus F minus. Group 7 gain 1 electron to complete the outer shell. Group 2, magnesium, third period, group 2, loses 2 outer shell electrons to complete its outer shell. So you have got 1 and 2. This is how many of the ions you need following the valency, which was based on the charges. We just bring down the value. -1, the value is 1. Crisscross year 9, exchanging the valency, 1 of the Mg2 plus, 2 of the F minus. So 1 of the Mg and then 2 of the F. This is called magnesium fluoride. That is called formula. They want the name, they don't want the formula. Magnesium fluoride, spell it with the IDE for the F minus. Fluorine is the element with the I and E then. And that's it really overall for this work 2 associated with the combined science or the coordinated science metals topic. Thank you for watching. Don't forget to click the button on the bottom right to subscribe to my channel. Follow me at ptet.chemistry, that's at ptet.chemistry on Instagram, Facebook, Twitter, and Telegram to get connected. I'll see you in the next tutorial video. Thank you for watching again.